Hey guys, it's Brandy Crowley. I want to thank you for taking your time outside of class to watch these presentations. I'm so sorry that I did not get to phone in and present the other night like I had intended. We just happened to be in a part of Texas that did not have the internet capabilities that I just thought it would have. Had I been able to present the other night, I just knew I was going to feel like Sheldon Cooper here in this episode, where he decided he was going to stay in his room and, be a robot and talk to everybody. That's how I knew I would feel, me sitting in the car trying to present from so far away. We're going to talk about nested systems of numbers. And when I thought of this, I thought of the Russian nesting dolls and how each one fits within the other one. And as we go through the presentation, we're going to see how this relates to our actual number system. The other night, I was going to do a quick formative assessment with you. So I want you to think of which of these is an example of a real number. And of course, all of us know after having done our reading that that would be all of the above. Rational numbers, integers, and natural numbers, all of them are real numbers. I was also going to have you draw a representation of real numbers, rational numbers, and integers that makes the most sense to you, what made sense in your mind. So since we can't draw it here on this presentation, I just want you to stop and get a picture in your head. What representation of our real number system makes the most sense to you? Okay, so we have our number line. This is our geometric representation of our real number system. It shows our origin, it shows our positive numbers, it shows our negative numbers. The problem is that we don't get to see all the layers that our number system truly has with this geometric representation. So I went around looking for some other representations of our number system. This one uses circles to show the different parts. We see our real numbers, and then we see that it breaks up into two groups, irrational numbers and rational. And then from our rational numbers, we see our integers and our natural numbers. And so to me, that yellow circle with that green and that brown in the middle, that's where that concept of the Russian nesting dolls really comes into play, how each little part fits into the other. So a natural number is still an integer, those are still rational numbers, and then those are still real numbers. This representation here did pretty much the same thing, they just saw it with rectangles instead. They went a little bit deeper. They went from rational numbers, integers, whole numbers, natural numbers. This representation was a tree map, so it showed what we started with our real numbers and then broke down the pieces from there. This representation is the one from our textbook. We can see in the middle we have our 0, and from there we have our circle with our integers, that is green, and then we have our rational numbers in pink, and then we have our real numbers in blue. What I like about this, going back to those Russian nesting dolls, is that, okay, the green is still part of the rationals. The integers are still part of the rationals. The integers and rationals are still part of the real numbers. Another thing that I like about this representation is the dotted line down the middle showing that one side, the right, is our positive numbers and the left side is our negative numbers. So let's think back to our number line that we had. We could easily see there was the origin, 0. We have our positive numbers on the right, our negative numbers on the left. But now we can see all the different layers that our number system truly has. So I was going to give you a second to think of what would be a benefit of that graphic organizer over the other ones. And of course, there were several options you could have picked. You might have liked the fact of how it was colored, how you could see the middle circle and then the circle a little bigger outside of it and a little bit bigger as we got to the real numbers. You might have liked the fact that it was broken down the middle so you knew one side was positive, one side is negative. This is a piece of our Conroe ISD scope and sequence. This is actually 6th grade, and this is the first time that they truly are looking at the entire number system. And the TEK is 6.2a, Classify whole numbers, integers, and rational numbers using a visual representation such as a Venn diagram to describe relationships between sets of numbers. So prior to that, in elementary school, we talk about whole numbers, but a lot of teachers may not necessarily use that terminology. We talk about fractions, but we don't talk about which part of the system that truly falls under. It's not until they get to 6th grade that they actually do start seeing this system. Let me go back to our picture here that we had here. So for our elementary students, they're going to stay on this positive side. They're going to start off with their integers. They're going to get into their rationals when they get, let's see, fractions. They start looking at fractions in 1st and 2nd grade, but they don't get to decimals until they get into 4th grade standards in Texas. It's not until they get to 5th and 6th grade, especially 6th grade, where they start seeing these kinds of representations and talking about the entire system. This is our instructional information piece from our scope and sequence, and you can see the 2 diagrams that they decided to include here. One being this circle diagram showing each of the pieces, and then this being a tree diagram. So this is a video that I actually had the pleasure of being in a 6th grade class, several 6th grade classrooms, and watching as they were working with the kids on this concept. So I wanted to show you a piece of this video.
Natural numbers are naturally numbers you count on your hands and your feet. 1, 2, 3, 4, 5, 6, and so on. Whole numbers are natural numbers plus 0. That's the only difference. 0, 1, 2, 3, and so on. Integers are whole numbers plus negatives. They look a little bit like this. -2, -1, 0, 1, and so on. Last but not least, not to be outdone, rational numbers are integers and fractions like -3, 1/2, 5/8, and 14.2. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. Now listen to that drummer. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers.
What I love about this video is that not only did it tell what each of the pieces were, it also showed 2 representations. The frame before this one showed it as almost that nested, that square and then a little bit bigger and a little bit bigger. But then this one truthfully is looking at the number line. You can see the green numbers at the bottom in an almost number line format, and then showing, okay, well, the natural numbers start at 1 and move toward the positive side, and then we have our whole number, and then we have our integers, and then it talks about our rational numbers. So I really appreciated the fact that this video related it back to that geometric representation of the number line. So we need to think about the fact that our number system is built on one another. As we got different numbers in history, it didn't get rid of the old numbers. It didn't become a system of its own. They just built on one another. So we have our counting numbers that we started with, our whole numbers, and it just kept building and getting bigger and bigger. Hence the relationship to this nesting dolls, the Russian nesting dolls. So our geometric number line is a great representation, provided that we teach the pieces. And what happens, sadly, is a lot of times teachers teach each of the pieces of the nested number system in isolation. They teach it as, okay, let's learn about whole numbers. Now let's learn about integers. And they don't take the kids to that point where they realize they all are related to one another. They all fit into this system that fits onto this number line. It all goes back to the number line where all of our numbers exist. Thank you so much for listening to my presentation.